Welcome to qnawire.
So for each of these countries, what we're being asked to do is to write a population model according to the P of T function above to represent their population for T years since 2000 in terms of millions. Well, remember, in our population formula, P sub 0 is the initial population, E is that constant, K is the rate that's increasing, and T is the number of years. So in this particular case, because T is the years since 2000, that means 50 would be our initial population. So it would be equal to 50. Okay, well, P of T represents the population at a particular time. Well, we know the population in 2010 was 66 million. So 66 would be P of T, which means that T would be equal to 10. So now we can go ahead and solve this equation. So the first thing I'm going to do is divide both sides by 50. So we can reduce 66 over 50 will be 33 over 25. And now, because we're using base E, I'm going to now take the natural log of both sides. So we're going to have the natural log of 33 over 25 equal to the natural log of e to the 10k power. And we do this because one of our properties of laws says that the natural log of e to the x is simply just x. So in this case, the natural log of e to the 10k power will simply just be 10k. So now we'll have the natural log of 33 over 25 equal to 10k. So now to solve for k, we just divide both sides by 10. Perfect. Now that we've isolated k, we can go to our calculator. So we're going to have the natural log of 33 divided by 25 divided by 10. And in this case, it looks like they want it around 5 places after the decimal. So you would find that k would be approximately 0.02776. So now that we have k, we can write our formula. It will be P of T equals our initial value, which was 50, times e raised to the 0.02776 times t power. So that will represent the population for Congo. Well, now we have to do the same idea for Turkey. Well, for Turkey, we were told that in 2000, the population was 67.4 million, and in 2010, the population was 73.7. So again, we're going to substitute in our values. So in this case, P of T is 73.7. Our initial population is to 67.4, and this is getting multiplied by e raised to the k times 10 power. So we're going to solve for k the same way. First, we'll divide both sides by 67.4. So we'll have 73.7 divided by 67.4 equal to e to the 10k power. Next, we'll go ahead and take the natural log of both sides. So the natural log of 73.7 divided by 67.4 would equal to natural log of e to the 10k power. But remember, according to our properties for log, the natural log of e to the 10k power is just 10k. So that means we have the natural log of 73.7 divided by 67.4 equal to 10k. So now, to solve for k, we just divide both sides by 10. So now, again, that we've isolated k, we can go to our calculator. So the natural log of 73.7 divided by 67.4, all divided by 10, and again, we're rounding 5 places after the decimal, would be approximately 0.00894. So now that we have k, we can go ahead and write the function. It would be P of T equals the initial population, 67.4, times e raised to the 0.00894 times t power.